Okay, so 2 sections ago we found the area of regular polygons, and to find the apothem we used 30, 60, 90, and 45, 45, 90 triangles. Well, now the angles aren't going to fit those formulas, so we're going to have to go back and use our trig function. So I wrote up here at the top, which you may need to jot down again, SOHCAHTOA, so representing the S as being sine, the O being opposite, H being hypotenuse. CA, C standing for cosine, A standing for adjacent, H standing for hypotenuse, T tangent, O opposite, A adjacent. Okay, so we're going to still be using the formula from 2 sections ago where we have to do a half times apothem times perimeter. So here's my first one where it gives me a nonagon with 10 centimeter sides. And so I went ahead and found my angle measurement. So that means I did 360 and I divided by 9. And when I did 360 divided by 9, I got 40. And so then my apothem split that in half, so that's why this angle measurement is 20. So then also remember your apothem splits the side in half, so that is 5. So now I look to see what my sides are compared to my angle. Remember, this is hypotenuse, opposite of the right angle. The side opposite the angle is opposite side, and then the side that touches it is the adjacent side. So since I have labeled the opposite and adjacent side, I would want to use tangent because of what the sides were. So I do tangent of my angle, so tangent of 20, equaling the opposite over adjacent, so 5 over x. So now I have to solve for x. So I have to times by x since I'm dividing over here. So I times by x, which crosses that out and gets rid of the fraction part. So now I have x times 20 over here, or x times the tangent of 20, equaling 5. Now I want to get x by itself over here, so now I'm going to divide, since this is times, so I divide both sides by the tangent of 20. So now on my calculator I type in 5 divided by tangent of 20, and that gave me 13.7. So then in my area formula, I do a half times the apothem, which we just found, times my perimeter. So remember, perimeter is distance around, so I'm going to do 10 times 9 since there's 9 sides, so that's why I got perimeter as 90. So then I times all 3 numbers together and I get 616.5 centimeters squared. Okay, so there's these big problems again, so I want you to pause the video and see if you can do the got it question. Okay, so in the got it question, we have a regular pentagon with 4-inch sides. So I went ahead and drew a triangle over here, and I did 360 divided by 5, which is 72, and then I got 36 when I split that in half. So then my apothem split the side length in half, so that's how I know that this side is 2, and I'm trying to find my apothem. I have labeled the opposite side and the adjacent side to this angle. So that tells me I want to use the tangent of 36. So I use tangent of 36 equaling my opposite side over adjacent. So I have to first times by a because I'm dividing by a, so that way a is no longer in a fraction. So then my new equation says a times the tangent of 36 equaling 2. Now I want to divide by the tangent of 36 since a is over here. So in my calculator I type in 2 divided by the tangent of 36 and I get the apothem of 2.8. So now I can plug in 2.8 for my apothem. I can then go ahead and find my perimeter. So 4-inch sides with 5 sides means that I could do 20 times or 4 times 5. So then I times all 3 and I get this answer. Now remember, there's 2 different answers. 1 when you round in the middle, or 2 when you round at the end. So that's why I was showing you which one, and honestly I don't remember which one is which for this, so bear with me and just know that it's one of those 2. Okay, so the other kind of problem then It's still doing the same thing, but they are not giving you a side length, they're giving you a radius. So here's my problem. It said a stop sign is a regular octagon, so I went ahead and drew that. The standard size has a 16.2 radius. So radius means it goes from the center to a vertex. So make sure you're drawing from the center to a vertex and labeling it 16.2. Then it says that I need to find the area. Okay, so I labeled this as 16.2. I need to find my angle. So I did 360 divided by 8, and then I did half of that to find this angle measurement. So this angle is 22.5. I need to also find my apothem, and I have to find my side length. So there's going to be two trig functions I have to do. So let's start with the apothem. If I compare the apothem and the hypotenuse to this angle, that would be adjacent and hypotenuse. So the trig function I would want to use for the apothem would be cosine. So I would do cosine of 22.5 equaling the adjacent side A over the hypotenuse 16.2. Then I would come over and start solving. So I would times both sides by 16.2, which cancels those out and gets A by itself. So all I have to do is type in my calculator this expression, and you end up rounding to 15.0. Now what I need to do is I have to come back and find my side length because I don't know my sides. So now I come back and I compare this side and this side with my angle. Well, this side length is opposite this angle, and this is the hypotenuse. So opposite and hypotenuse means I need to use sine in order to figure out that measurement. So I would do sine of 22.5 equaling my opposite over my hypotenuse. So that's how you would set up for your side length. Then I start solving. So then I would times by 16.2, which cancels that out. And then in my calculator, I would type in this expression, and I end up getting 6.2. So what we just found was the apothem is 15, but I only found half of the side length. So remember, I need a full side length, so I would have to double that and get 12.4. Then to find my perimeter, I would then have to go back and take it times 8. So to find perimeter, I would take that 12.4 times 8, and then I can plug it into my formula. So I would do a half times my apothem times my perimeter, and I end up getting one of those two answers, which I don't remember which one it is, but one would be when you round in the middle, one would be when you round at the end. Okay, that's a long process, so pause the video and see if you can try the next one. Okay, on the next one, we have a decagon, so 10 sides with a radius of 9.5. So what I did is I just drew one triangle of what I would need to find. The radius means that's going to be the hypotenuse of my triangle. Then I went and found my angle measurement, so I did 360 divided by 10 and then split that in half, so that's why this is 18. I need to find both of those measurements. So let's start with the apothem first. This would be adjacent and hypotenuse, so I would need to do cosine of 18 and then set it equal to the adjacent over hypotenuse. So you want to times both sides by 9.5. So your apothem should be around 9.0. Then I need to come back and find this length right here. So this would be opposite and hypotenuse. So I want to use sine this time. So I do sine of 18 equaling x over 9.5 or whatever letter you like. And then times by 9.5. So I would just type this expression into my calculator, and I found that that side length was 2.9. Now remember, that's only half of my side length, so I would need to double that to find the actual side length. So you would get 5.8 as the actual side length, and then you would need to find the perimeter, so you would need to take that times how many sides, which would be 10. So now I get to plug everything into my formula. So I have a half times my apothem number times my perimeter number, and I end up getting 261, or if you round it differently, maybe 265.2. Okay, so remember regular polygons, you're still using a half times apothem times perimeter, but you're going to have to use the trig functions to figure out your missing links this time.